All right. Let's go ahead and look at this. Everybody say, hey, Noah.
Hey, Noah.
Where's my microphone? Oh, my God. You go away, and you come back, and everything's everywhere. Oh, here it is. Did y'all say hi, Noah? Yeah, he's good. I'm recording this so that Noah can. Okay, what are you talking about, Jaden? Alright, here we go. Alright, so today we'll learn about systems of equations. A system of equations, are we listening? System of equations is a set of two or more equations that use the same variables. Okay, so if the graph of each equation is, or equation in a system of two variables is a line, then this system is a linear system. So that's what we're going to focus on. We're going to focus on linear systems. Okay, so lines. Just two lines on a graph, same time, boom. All right? Okay, so this is an example of a system of equations because it's two linear equations using the same variables. So if we look, we're both using y's and x's. Okay? And it's in this little brace or bracket. Okay, I tried to draw that sideways and I couldn't. So, do y'all think you can draw that? A little swooshy. You don't have to draw it if you don't want to, but I think they're fun. That's the wrong way, though. Okay, so also I didn't know that this was going to be super tiny. Okay, so when you're asked to solve a system of linear equations, that means what ordered pair will make both equations true. So that means when we plug in x and y, you'll get like 3 equals 3, or 18 equals 18, -1 equals -1. Okay? So, let's look at this one right here. So, step 1, all problems need to be in, y equals mx plus b form. Okay, so that's how we've been graphing, right? So now if we're not graphing, it doesn't need to be in that form. But if we're graphing, it's very helpful to be in that form. Okay? If your problems are not, solve for y first. So if I look here, I'm going to, which problem is not in y equals mx plus b form? The first one, right. So the second one is fine, right? I can graph that straight away. So I'm going to look, how would I get y by itself? Add 4x, right? Because this is a -4, so I'm going to add 4x to both sides. So y equals, so the x part comes first, so I'm going to put that 4x in front. And then it's a -3. All right, so now I've got these two lines. So next you're going to graph the equations on the plane. Because today we're solving by graphing. So there are 3 ways we'll solve by graphing, substitution, and elimination. Okay? So, my first one here, where do I start? Did someone say something? +3. On which axis? Perfect. So I'm going to start at 3. So 1, 2, 3. And then I'm going to, my slope tells me to go down 2, right 1. So down 2, right 1. Down 2, right 1. All right, this graph is a little wonky. I think it didn't. Sorry about that. All right. The next one, I start at -3. 1, 2, 3. And my slope says up 4, right 1. And we go off. I didn't mean to make this one here. All right. So, do these lines intersect? Yeah. Okay. So, how many solutions does it have if it intersects? One solution. So, locate the intersection of the two lines. So, that point is 1, 1. Okay, so that's our solution. All right, the next part, the last part is chickadee check yourself before you wreck yourself. So check the solution. So that means our point is 1, 1. So I'm going to plug in 1 for x and 1 for y in both problems. So y equals -2x plus 3. So I'm going to plug in 1 for y and 1 for x. Oh, that's a -2. Whoops. So I get 1 equals, so that's -2 plus 3, which is +1. Does 1 equal 1? Yeah. So then that is a solution for that line. Let's check the other one. Yeah, hold on a second. Okay, the next one, y equals 4x minus 3. So I'm going to plug in for 1 for x and 1 for y. 4 times 1 is 4. 4 minus 3 is 1. So does 1 equal 1? Yeah. So since we get a true solution for both of them, then that means that this is my real solution to the system. All right? Okay, it's 10:38. So go ahead and take your math break. Be back at 10:48. Okay? So if we have 2 days in a row where people are late, we're going to go back down to 5 minutes.
Literally just said that.
Damn, Maple. So I walked in classroom first and I was like, of course. Dude, I messed with it though. You know what I said? I said bacon. When he said bacon.
All right. Okay. So what I want us to do is get out a whiteboard. Oh. The graphing side, because today we're solving by graphing.
I don't have a graphing side.
So we need the graphing side. What?
There's no graphing side.
Girl, you lying.
No, look.
Girl, I literally saw you flip it earlier. You were like, there's no graphing side.
There's no graphing side. I'm turning it around, but no graphing side.
All right. We ready? Do we have our... Do I need to take phones like I do with my freshmen?
Is your freshman class your last one? I'm sitting right here. Mine's sitting right here.
We paying attention to you.
You ever grabbed out?
You gotta stop.
It's okay. Okay, Jenny.
Calm down.
I know.
You have Ebby, right?
Mhm.
I've known her since she was just a little kid. I used to carry her around in my head.
She's sweet.
Is she smart? Yeah, she's in 8th grade. Oh yeah, she's a genius.
All right.
Yeah.
So, I want you to graph these two lines. I want you to circle where they intersect. Listen. What are we supposed to do?
Graph the two lines and circle where they intersect.
Connor, what do we say?
Yeah.
Alright, so y equals 1/3 x plus 5. Y equals negative 5/6 x minus 2. So graph the two lines. Then circle the solution. What would the solution be?
Where they intersect.
Where they intersect.
Did you make good grades in all your math classes
In high school?
Yeah.
I can't remember if honors algebra 2, if that was the year I made a C. No, I made a B, but that was only because of the 3 points.
Do you still go up?
Well, you got your papers, but you can still do that. So you started at 5. Down 5. Right. Yeah, you might have to, yeah, you still have to do the whole, as Jaden said, the whole outline.
Is this right?
Shot.
Huh?
Shot. Alright, if you see your neighbor struggling, help them out.
Are you struggling with anything? Did you get it right? Actually, yeah, that's
Oh, just. Okay, what's happening? So this, there you go, yeah. Your first line's right. Shot. Yeah. Alright, I also like how people are writing down the coordinates. I love it, I love it. up their boards.
Wait.
Okay, sorry.
I'm so close.
You're so close. It was true.
How
Okay.
many do not?
Cool. Love it. Connor, what do you gotta do to the intersection? There we go. So, cool. Label something happened because
Yeah, something happened. I don't know what it
that's where you should have intersection.
is.
Down one, right three. It should be key. Did you start? You didn't start it. You started at 4, not 5. Alright, so here we go. This is what yours should look like.
Oh, we talking about that.
Alright, so raise your hand if that's what yours looks like. Now wave it in the air like you just don't care. Hey, oh. Alright, so does this have one solution, no solution, or infinitely many solutions? One solution. Dude,
I'm texting my book.
are you texting her? Man, I just learned what the solution was to these lines. It was awesome.
I'm texting her.
Oh my gosh. Telling me to put my phone away. Alright.
I'm listening to this.
Alright. So, we have one solution. Okay, so we call this consistent. Okay? Alright. So, thank you. Alright, we're going to do this again. Now, these are the easiest lines, but everyone has trouble graphing them. So, y equals x and negative x. Where do I start? You start at 0, right. So both of these start at 0. What's the slope here? Of 1 over 1, right. 1 over 1. What about this one? Down 1 over 1. Alright, so graph those and circle your intersection. And I would like you to label it.
When
And
it intersect at 0?
not just 0. 0, 0, 0. Right, they intersect at an x and y coordinate. So you just gave me 1, so I need both of them. But yes. Alright, and then I want you to write if it has one solution, no solutions, or infinitely many. The other one. Right there.
Nothing just associated with
Save it over there.
yeah, the dude died. He like
Alright.
he overdosed and like started seizing in the drive.
Go ahead and raise your boards. Let me see. Let me see him. Let me see. Luis, do you have a board? Oh, okay. Alright, so it should look like this. Alright, we've got 0, 0. We've got one solution. We've got the lines graphed. So if you got it right, wave your hand in the air like you just don't care. Say ho. Alright. Thank you, Connor. Let me pass that back to Connor. Thank you. Okay. Now I want you to graph the line. I want you to graph the line negative 2 thirds x plus 3, negative 2 thirds x minus 4. Go ahead and graph those. Graph it. You want to graph it.
You bet that. Dude, I got no paper here. Yeah. Wait, why don't you? There we go. We're graphing.
1 point.
You're instructing us to graph it. My time, that's the focus.
Oh, your line went a little. Loved it. I love how we're writing what type of solution we have. I'm crazy. I don't know. Oh, I'm cringy. No, just have. All right. All right. So your board should look like this. Is that what it looks like? Awesome. Wiggle your board if that's what yours looks like. Okay. So we have no solution. Why do we have no solution? They're parallel. They don't intersect. Awesome. Brandon, how did you know that these were going to be parallel?
Because it didn't touch,
Awesome. So let's look at, okay. Yeah, that's fine. All right, so let's look at our equations here. Okay? What do you notice about our equations?
They both got the 2 and 3.
Okay, so they both have, she said same slope, so then we have, Jane said they both got that -2, 3, right? So if they have the same slope, what's going to happen? They're going to go the same way, right? So are we going to have an intersection? No. So let's look at this other line. So y equals 4x plus 2, y equals 4x minus 3. So before we even graph, what can we predict about those 2 lines? They're parallel. Why do we know that? The slopes are the same. So if we have the same slope, they're parallel, which means what? They don't cross, so how many solutions? No solution. All right, so go ahead and graph those. And then let's see if we're right.
So we gotta graph it.
Yeah. Yeah. You've got to graph it. Oh no, that's. You need to graph it. Go ahead and graph it. If you need help, ask me or Bud. Graphing blue, sorry. No, you're not. You're at +2, right? Did I use that at -3? Yeah, it's just going to be D. Alright, so you are going up 1 and right 4. It's going to go up 4, right 1. Alright, I want you to check your partner's board. If you have the same graphs, I want you to give them an air high five. Because COVID. Air five. Alright, check with Becca, see if y'all have the same. Air high five. Alright, Ethan, what happened? You're starting at, you started at the x-axis. Yep. So make sure we start at the y-axis. So I've got 2 and -3. So I saw a couple mistakes. The biggest one was somebody, I'm going to call you out, Brandon. Is that okay? I guess so, because I already said it. Okay, so Brendan went up 1 and right 4, but what should our slope be? Up 4, right 1. Okay, so up 4, right 1. So then we've got up 4, right 1. Okay, so we've got really skinny lines here. Did I count 5? 1, 2, 3, 4. Nope. 1, 2, 3, 4. Okay. So you should have boards that look something like this. All right. So let's graph one more. All right. I want you to graph. I want you to graph 2x, and I want you to graph negative 3x plus 1. So graph those two. So where does that 2x start? At 0. Nice job. Yeah. So go ahead and graph that. So we're graphing these. Well, I'm doing a great job, by the way. These might not intersect at a clean point or at an integer, but because I just made them up. But they might do that. Well, okay, 'cause it would be close to 0. Alright, so this one, a little funky, but that's okay. So 2x plus 0, so I start at 0, up to right 1. Down to left 1. Alright. The next one, where do I start? At positive 1. These were almost the same color. Okay, and then I go down 3, right 1. 1, 2, 3, 1. 1, 2, 3, 1. Up 3, left 1. So they don't cross at an integer. Okay, it kind of crosses right here. Kind of crosses in between 0 and 1. Okay? So they kind of cross in between 0 and 1, which is not an integer like we're used to, but that's okay. Most of life is not about integers. Okay? Most life is about decimals. Okay? Alright. So if they cross, how many solutions? One solution. What if they have the same slope? No solution, because the lines are parallel. All right. Okay, so solve the system by graphing. So step 1, we talked about earlier, they have to be in the same, okay. So step 1, they have to be both in slope-intercept form. Are these in slope-intercept form? No, so we got to get them there. All right, so x plus 2y equals negative 7. So first I need to subtract that x. So I have 2y equals, I'm going to put the negative x in front so I keep it like the y equals mx plus b. Okay, is y by itself yet? No, so what do I need to do? Divide by 2. Awesome. So I have y equals, if I have x over 2 like that, it's going to be 1/2. Negative 1/2 x, and then minus 7 over 2, that is 3.5. So you go to 3.5. Cheese and crackers, I didn't know they were going to be that small. So I count 1, 2, 3, and then I go halfway. Now you have to count the half each time. Yeah, actually I want to because it's so small. So let's skip that one. But let's go ahead and practice solving the other one so that we have good practice with that. So I have 2x minus 3y equals 0. So we're gonna. This is the first one. This is the second one. So let's practice solving first. All right. So to get the y by itself, what should I do first? Minus the 2x. Perfect. So negative 3y equals negative 2x. I do not need to write the plus 0. Okay, and then what's my last step? Divide by 3. Negative 3, yeah. All right, what happens when I have a negative and a negative? It becomes a positive, so it's 2/3 x. All right, so we won't do that one because the graph is super tiny. And to graph that first one, we would have to do, so start at 3.5, right? 1, 2, 3.5. And then from there, my slope was negative 1/2. I would have to count by halves. So 1, down 1, right 2. So that would be my other point. It'd be another half. Okay? Okay, so we'll skip that one. That was good practice to solve. All right, so are these in y equals mx plus b form? No, so let's do that first. So I'm going to subtract 2x from both sides. Is y by itself? Now that I subtracted the 2x from both sides, is y by itself now? Yeah. All right, so I'm good there. And then this one, I would add the x to both sides. I'm going to put the x in front to keep with the y equals mx plus b. We want that x number to be in front. So I have y equals x plus 2. All right. Now, so do these have the same slope? No. Are they the exact same line? No. That sounded like a trick question, but they're not, right? So that means how many systems are we going to have? I mean solutions. One solution. So go ahead and graph these. All right, the next one. Where do I start my line? At this one here. At positive 2. And my slope is up 1, right 1. All right. Was our prediction correct? Do we have a solution? Yeah, so let's go ahead and circle it. And what is our solution? So what point is that? 1, 3. Perfect. Now, so remember the last step was to check ourselves before we wreck ourselves. Okay. So we've got, I plug in, you can choose either one. I'm going to just choose these. So I'm going to plug in 1 for x and 3 for y. So 2 times 1 plus 3. Okay, so that is 2 plus 3, which is 5. Does 5 equal 5? Yeah. So then that's good. I'm going to plug in 1 for x and 3 for y. Negative 1 plus 3 is 2. Does 2 equal 2? Yes. So then we did our work correctly. What's the next page? Okay. See if I remember all my vocabulary. Okay. If a system intersects in one place, we state that the one solution, that there is one solution. And we say that the solution is consistent. Or we say independent, sorry, independent. Does anybody else sing that song when they're trying to spell independent? I-N-D-E-P-E-N-D. No? Do you know what that means? No one knows that song?
I do that for restaurant.
R-E-S-E-C-T. So that is one solution. Alright? If a system is the same line, so you end up graphing the same line, so they're kind of on top of each other like this. Okay? That one is called dependent. So infinite solutions. So let's draw an example of 2 lines crossing. Those are the worst lines I think I've ever drawn in my life, so sorry. Alright, if a system never intersects, then the lines are parallel. If the lines are parallel, what do we know about their slopes? Same slope, right. This system is inconsistent. Okay, so no solution. Alright, let's see. Look at the back. Oh gosh, those are so tiny, it hurts my eyes. Alright. They're so tiny. Okay, so let's just try to write down the equation for this one. So Mulan and Lilo are competing to see who can sell the most candy bars for a fundraiser. Mulan sold 4 candy bars on the first day and 2 each day after that. So hers is going to be 4 on the first day and then 2 per day. So that 2 per day lets me know that that's my slope. So this is Mulan's. Lilo's is, he sold 7 on the first day and 1 each day after that. Okay, so we don't have to graph this because it's kind of hurting my eyes a little bit. Okay, but that's how you would write those equations. And then find the solutions to the system. So let's go ahead and circle where they cross. Okay, so I just want you to circle them. Okie dokie. So I think on Delta Math, I have your homework. see if I do. Yeah, so guys, the homework is Module 3, Lesson 1 on Delta Math, solving linear equations. I know, right? So, you have 8 problems to do in like 25 minutes. You think you can do that? Oh, wait, I forgot about your exit ticket. So, go ahead, do your exit ticket, turn it into the basket, and then work on your homework. Huh?
It says, how many solutions can a system of 2 lines have? It says 3 answers. They're talking about these.
What shoes do you have to say? What shoes do you have to say?